Hi, everybody. It's great to be here. I'm very excited about talking about service workers, and I'm sure you all here are also. So let's get right into it. So before we go into service workers, I wanted to briefly touch on the history of the web and how we relate to native. So before, we had this very disparate world where the capabilities of the web and native were very different. And we've been trying to bring that ever so closer. So what we had to do was, us and along with other browser vendors, we took to the standards bodies like the W3C, and we came up with a bunch of cool new features, bunch of new capabilities that are now in the web, that are available that you can use. And these are just some of the few. So we came from a world that looked like this, where the capabilities were very far apart, to a world that's very much closer. And so you're able to take advantage of much more greater capabilities in the web, like you can with native. And so touching back on what Krupa was talking about in terms of the PWA principles as they were, I'm going to be focusing on two of those things. We're going to be talking about working offline and reliably under poor network conditions, and also being able to send push notifications when the browser is not open. So to start working offline and the poor network conditions scenario. Today, in a native application like the weather application in Windows, this app actually works while you're offline. And you can tell that there's some text there that says updated as of 8:40 p.m. And that's pretty neat. They're able to do that. In the web, you get this. And that's not really cool. And you also get this in any browser. It's not like it's specific to Edge. And the other thing is that you're also able to send push notifications in a native application. So in the case of some app here, you will get the notification for a weather advisory. There's extreme heat in Hawaii. Lucky them. So in the web, what you're going to get is nothing. And that's kind of sad. So in 2012, we were able to do offline the web. And this is sort of what it looked like. If we had a weather app that we were building, it would load. And it would show us some cached content. And the way that we did this is we used something called application cache. And this is what it looks like. Just FYI, at the top right corner, if you want to follow along, you can visit the gist and also see this code and follow along. So here we have an HTML file that we are defining the manifest for. Here it's appcache.manifest. And in that manifest file, we declare at the top cache manifest. And underneath that, we can declare other sections of that manifest, like the cache header, and we can define the types of resources we want to cache. Here, we're caching CSS, JavaScript, and images. And then, of course, if you have something that you didn't declare here and you didn't want to cache, you want to be able to also let it go through the network. So you're going to have to create this network star wildcard that will pretty much just say, if it doesn't match those rules above, we're going to go to the network and get that from there. And then also, if you have a request that couldn't go through to the network and you wanted a fallback, you can do that here too. You can just define a URL pattern and then have it go to a fallback. So that's all well and good, but most of you must have heard Jake Archbold had some choice words here about application cache. I'm told I can't say that word, but if you want to follow the link, you can find out what it is. And so app cache has some gotchas to it. Namely, you have to update that manifest file if you want to see any of your cached files changed. So if you do a little bit of a comment change, then that'll do the job. Also, if you cache that manifest file, you've actually doomed the user, because now you can never get an updated site ever again. It's sort of just cache that file. So that's no good either. And you're also, any file that comes through the app cache has to come from the app cache. So if you have a resource that you didn't necessarily intend to come from the app cache, well, that's too bad. It's going to come from the app cache. And that's even if you're online. And this might not be something you expect when you use app cache. And that's partly because you don't really have much control there. And that brings me to another point here, which is a lot of it is statically defined. You don't get a lot of programmatic control. If anything goes wrong, anything goes awry, you don't really have a point of recourse. So in essence, it's magical and it's difficult to debug, and it basically gives you no control. So app cache is useful, but we can do better than that. And what we want to do here is we want to give some control back to you, the web developers. And to do that, what we first have to look at is network requests, those actual requests to the resources that we were talking about before. So we're going to introduce a new concept called fetch, and it works like this. First, let's talk about how it works in the current world today. You have your page. It makes a bunch of requests to a bunch of stuff, like your HTML, your CSS, your JavaScript, your images, your XHR calls, whatever it may be. And from there, we go to the network, and you get your resource back from there. So what we're going to do instead here is we're going to go and abstract away all of these requests into this fetch magical box that's going to then go to the network. And this has some very cool side effects, because now we have all these algorithms in a black box that we can expose to JavaScript. So what we're going to get here is we're going to get the fetch method that you can actually use to do any of these network requests. We also get the primitive request and response objects that we can use as well. This is what this looks like. So if we're going to use the fetch method at the top there, we're going to pass in a URL. We're going to do weather.json. And here it's promise-based, so we're doing .then, which basically means once this request succeeds, we're going to handle it and we're going to do something with it. And if you're not familiar with promises, please do read up on them. They're going to be used all across with service workers and fetch, and it's good to know this. So what we're going to do here is, again, you're getting a response object, so you can get the headers from there and and get a content type header, and then we're going to check if it's application/JSON. If it is, that's great. We're going to return JSON, which is a special method that you can use that'll just make it easy to extract the JSON data from that response. For comparison, this is what it would look like if you did this with XHR. It's a lot lengthier. It's not as pretty. But aside from that, actually this, under the covers, is going to call fetch inside the browser. So it's still using the fetch algorithms that we just talked about. So again, back to our model here, where we are going through to get all of our resources. We're going through fetch, but we're not done there yet. We need to do something else to really give you control. And the best idea here is to have some sort of worker, something that could basically give you the request from that fetch and pipe it through to there. And you may be thinking web workers, but I'm thinking something even different. I'm thinking service workers. So service workers, what are they? Today, when we make a request to a server, it goes right through, and then we get it back. In this new world with a service worker, we are going to go through a service worker, and then it will come back to the page from the service worker. So we're going to cut the network out, but not entirely. And I'll go through a little bit of that in a bit. So in a service worker, you'd be able to do something like handle a fetch event. So we can do self.onFetch, which gives us the ability to handle that event. And in there, we're going to use event.respondWith. RespondWith is a special method that we pass in a promise that resolves as a response, or we can pass in a response here. And here we're just going to pipe it through using fetch and passing in the actual request that came through. So in this case, it's basically a no operation. You're doing what the network would have done anyways. And unsurprisingly, if we were to try this, if we were to try this in the app, you get nothing if you're offline. So it sounds like we still need to do something here, that our work's not done. We need to actually save these responses. We need to get these responses and put them somewhere. And that's a new concept, the cache APIs. This thing is going to... OK. So from there, instead of going right to the service worker and getting back from the service worker, what we're going to do is we're going to go through these caches and get it back from there, and then give it back to the page. This way, we're able to actually work offline. And so the caches are basically a key value storage mechanism, where the key is the request and the value is the response. And you have full control over these caches. They are bound to a domain so that they're secure, and so you can't reach into another caches. If you're on A.com, you can't go to B.com, for example. And so with this, you have full control. If you want to purge the caches, you got to do that. If you want to update them, you also got to do that. So this is very different than the HTTP cache in the sense that you, as the web developer, will use APIs to maintain the caches. So as you might be wondering, there is still another mechanism, this clicker, Cache API, and now we have, so now that we have that Cache API, we also have IndexedDB that is not to be forgotten as well. So if you're trying to figure out where you're going to put your data, think of it this way. If you have something that's URL addressable, you're going to put it in the Cache API. If you have something that is anything else, put it in IndexedDB. And this way, you still have an asynchronous way to get at the data that you need. OK, so now we're in business. We have something that lets us save the responses, lets us basically go through the network and get at those requests so that we can hijack them and give something back to the page. So first thing we're going to do here is we're going to register a service worker so that we can do some of this cool stuff. And the way that we're going to do that is we're going to call navigator.serviceworker.register, and we're going to pass in a JavaScript file, serviceworker.js in this example. We're also going to define a scope. Here I'm just using the default, but you can use any other directory here. So I can use /myweatherapp, for example, and only when I visit that page, for example, it will use this service worker. So it won't be for the entire domain, which may not be a good idea in some cases. Again, it's promise-based, so once that service worker registration is done, we're able to capture that and let the user know. And of course, if it fails, we can handle that as well. So to start with, the first step of the service worker is actually installing it. We're going to get everything ready and set up. And to do that, we're going to, in the service worker, install and prime the caches. And the way we do that is we do self.uninstall, and we're going to use this new method, event.waituntil, which basically lets us pass some promises in so that once these things are done, and if and only if these things finish, we're going to successfully register. And this will basically give you a way to guarantee that the caches you're going to cache here are going to be there the next time that you ask for them. So we're going to open a cache using caches.open. Cache is a global object in the service worker that you can use. We're going to call this cache static-v1. And then from there, we're going to use cache.addAll and pass in a bunch of resources that we want to cache. So that's great. We've registered now. But at this point, we've installed the service worker. We haven't activated yet. And really what's going to happen here is if there is another service worker that the page is using, we got to wait for that page to go away. So it needs to be closed, for example, before we can actually have that service worker activate. So the next step then, once those pages are closed off, we have that new service worker that can be activated, and it could start doing some things. For example, clean up after the previous service worker, if you're doing an update in this case. So what we're going to do here is we're going to do self.activate, and we're going to have a list of things that we'd like to keep. So we just set up assets-v1. We're going to keep those things, and we're going to delete everything else that we don't need. This is a little bit of a naive way to do it, but you can be a lot more reasonable about what things you want to keep and which things you want to delete. Again, we're going to use event.waituntil so that we can say once these things are done, we're basically allowing this event to finish. So we're going to get the caches keys, caches.keys, and it's going to give us the names of all the caches that we have for that domain. From there, we're going to use promise.all, and this is just going to take a list of promises. We're going to map the cache name list and basically have this function run through all the cache name lists, which is just checking if the item is in the keep list. If it's not in there, we're going to delete the cache by using caches.delete. OK, that's great. So now we're activated, and the service worker can now fulfill its destiny to handle fetch events. So the way that we do that, again, we're going to use self.onFetch, and we're going to use the caches API. So again, this is an async API, which is promise-based. And we're going to use caches.match and pass in the request that we just received from the fetch event. And this will basically look for it, and if we find it, we're going to return that back to the page. And in the case that we don't find anything, we're going to go to the network and fetch it and get that response back. And if all else fails, we're going to use .catch on that promise. We're going to see if we can use the fallback, so we're going to pass that back to the page. So at that point, the service worker then becomes redundant if it's being replaced by another service worker, for example, and if you're doing an update. So if you're going from version 1 service worker to version 2 service worker, it will be in the redundant state. So this is what this looks like now that we have it. We go to our fallback. So Our fallback says, please connect to the internet and try again. That's not really great. We wanted something better than that. We wanted to show something of value. So let's try to cache dynamically and get something that looks more like this. So here we're showing that it's grayed out because we're offline, but we're still showing something. So that's more usable to the user, and it will tell you when it was last updated, and that's very useful. So the way we do that is instead of on our onFetch, instead of doing what we were doing before with the catch and using the fallback, we're instead going to open up a new cache. We're going to call it dynamic, and this is for all our dynamic resources we're going to cache on the fly. And once we get those things, once we open up the cache, we're going to put the request and the response into the cache so that we have it basically for use later. And then we're going to take what we just got back from the request back to the page as well. And here we're going to use response.clone because once a response has been consumed, because it's a stream, we have to clone it so that we can still use it for another purpose because we just used it before to put it in the cache. So that's cool, but we can do better. In fact, what we'd really like to do is have a page that loads straight away from the cache, and then if we're connected to the internet or once the network finishes doing its thing, because usually the cache is faster, we're going to load it from the network. So what we want to do is make it work like this. So this is slowed down for the purpose of showing you what it would look like. But as you saw, it first showed the gray with the old data, but it had an experience. And then it showed it light up with the online fresh data. And to do this, we're going to change our fetch event here. What we're going to do is, if we're doing a request for the weather.json, we're going to respond with a fetch and cache. And I'm going to talk about what that method does in a bit. And if not, if it's anything else, for example, we're going to respond with what we were doing pretty much before, which is we're going to get something from the cache, and if it's there, we'll respond with that, and if not, we're going to fetch and cache. So fetch and cache is exactly what it is, what it's called. We're going to see if there's anything. We're going to open up the caches and then do a fetch for that request, and if we find it, we will then put it into the cache and then respond with it as well. So in the actual file, the page, the index.html, what we're going to do is we're going to race the network and the cache, and we're going to get the cache stuff first. So what we're going to do is we're going to show a loading spinner, for example, something that shows that something's going on, and then we're going to set a global variable that lets us know if the network is done yet. And then from there, we're going to have a network request that's going to fetch the weather.json. And if that succeeds, we get the JSON back and return it. And then we just set that network done to true so that we're aware that it's done. And then we're going to update the page with the JSON. At the same time, we are going to see if there's a match for weather.json in the caches. And remember, in the service worker, we were caching things dynamically. So if it's there, then we should be able to pull it out of there. If there is no response, though, if we didn't get the opportunity to cache it, then we're just going to throw an error. And if there is, we're going to bring out the JSON from that response. And then if and only if the network hasn't already gone back to the page, will we update the page with the caches. You don't want a situation where you just got the fresh content, and for some reason your cache was super slow, and then you're going to update it with the cache. You only want the other way around. You want the caches to load, and then a few seconds later, if you got the network data, to show the network data. And then if that fails, so if we don't get anything from the caches, then basically our last hope is the network. We're going to wait for the network. And if that fails, then we basically have nothing, and we probably want to provide an experience there. But in any case, we want to stop showing that loader spinner thing so that the user knows that we're done trying what we wanted to try. So we've covered basically two types of service worker events here. We've covered the lifetime and the functional events. We have the onInstall, the onActivate, and then we had the onFetch that we were just talking about. And you can imagine that this obviously helps us solve the working offline and reliably under poor network conditions, which I just covered. But service workers sound like they could do so much more. They're really an app model for the web so that we can handle any kind of event-driven event in this JavaScript worker so that it could do other cool things. Maybe we can also do push. So let's see what that looks like. You have your server. It sends a push out to your service worker on your machine, on your device. And then from that service worker, you will use event-driven logic that will basically handle the push event and then show a notification. From that notification, once you click it, you will then, in the service worker, handle the click itself as well and reopen the page that was intended from the notifications click. So this is what this would look like. You will have a permission prompt when you first visit, and you ask for permission if they want to show notifications, and we're going to say yes. So at this point, we're going to close out the browser, and we're going to get a notification that comes up, extreme heat until tomorrow. We're going to click that, and it's going to repatriate you back into the browser, back into the page that you were at. So this is what that looks like. On registration, again, navigator.serviceworker.register, we're going to pass in that service worker JavaScript file. We're going to get that registration object, and we're going to get the push manager in there and get the subscription. At this point, if there's already a subscription, if we're already subscribed to this push service, we're going to just return that subscription. If not, we're going to go ahead and subscribe through that push manager. And we're going to use that user visible only set to true, meaning that we're promising to the browser that when we show a push notification, we're going to show something. We're going to show a notification. We're not going to just do something in the background that spins on end doing nothing. And then in the service worker itself, we're going to handle a push by using self.onPush. And we're going to get at the payload data using event.data, and then we can get the actual text from there. This is going to be the message that we're going to show inside the notification. And then we're going to use event.waitUntil so that this has to complete before the event can finish. And so what we're going to do here is we're going to show the notification. We're going to pass in a title, and we're going to pass in the payload, which is the body, the thing that said that there was extreme heat until tomorrow. And we're going to also provide an icon so that it doesn't look like it's from some other application, so that people are aware of where it's coming from. So at the same time, we also want to handle the notification click. So we do that with the onNotificationClick event. And the way that we're going to do that is first, we're going to close that notification. We're going to dismiss it so that it's not there still. And we're also going to use clients.openWindow so that we can navigate the user to the page that we intend for them to land on. So that's great. We've covered two new functional events for the service worker, push and notification click. But again, this is event-driven. We can accomplish so much more for this. We can accomplish things like background sync, maybe geofencing, and sky's the limit. We can continue adding events to this web application model called service worker. So just to touch on a few properties about service workers, which are pretty important. First, to note, it's HTTPS only. If you're using a local environment, you want to use localhost, you will be able to use it there. But you can't use HTTP for security reasons. You don't want a man in the middle and have a service worker pretty much hijack all the requests and then do a bunch of stuff with it. Also, it doesn't have DOM access. So if you want to do anything with the page itself, you're going to post message to the page like you would from an iframe or a web worker, and you would be able to then let the page do something to its document object model versus the service worker itself, which has no access to that. If you have app cache declared for that same page and you also register a service worker takes precedence. In fact, it will not allow app cache to work if you have a service worker. So your original service worker script file cannot be on a content distribution network. However, you can use import scripts to use something that is on a CDN, but that original service worker.js, for example, has to be on the same domain that you're registering it from. And so another thing to keep in mind is that these service workers can be terminated at any time. So if, for example, you're under battery or storage pressure from the browser, they can kill these things off so that they're not doing anything. And then also keep in mind that only asynchronous requests are allowed. So you can't use synchronous XHR, you can't use local storage, you got to use IndexedDB and the caches API, and fetch instead of XHR. All right, and also keep in mind that it's executing separate from the page, so it's actually running in a separate context. That means all the globals that you've set on your page, just like a web worker, it would be completely separate inside of the service worker, so it has no sight into the actual page itself. And we talked a little bit about scope earlier. Keep in mind that there's a one-to-one mapping between the service worker and a scope. So if I've installed a service worker for /myweather app, for example, and I try to install or register another service worker for the same scope, it's going to update that service worker. It's not going to basically have two service workers. You can't do that. So obviously you might be thinking, this is all well and good, but can you use it? Well, so as you may already know, Chrome and Firefox already have it implemented, and you can try it out there already. Safari has shown some intent to develop as well, and we've been actively developing and working through a lot of the service worker implementation, all of these features we described. So we've been thinking a lot about it at Microsoft, and as Karupa mentioned, in the Fall Creators Update, you'll be able to, that's coming out in October, you'll be able to enable service workers in Edge using About Flags. And to remind you, you go to About:/Flags in Edge, and then you'll have the Enable Service Worker option right there. Just check that, and then restart your browser, and it should work. A few things you might want to note about F12, for example. Again, because these are workers, you can actually debug these things, not like App Cache, which you basically had to read a spec and understand exactly what the browser was doing. So one thing you should note is when you go under the Debugger tab and you see the service worker node on the left-hand side there, you're going to see a service worker overview page, and this is going to let you inspect the service worker, much like you would any other script. The difference here is if you click on inspect, just keep in mind that it's actually going to open a separate instance of F12 that is going to debug that service worker specifically. And again, it's like debugging any other script, so you can set breakpoints. Here's the JavaScript that we wrote for this app, in case you remembered it. You're also able to see the caches in F12. So on the left, there's a request URL, and then there's the response body on the right. So you're able to see what things were cached. And we can see the assets -v1, and we can also see the dynamic caches that we're setting up in the nodes on the left there. One thing to keep in mind, this is still experimental, and we are working through a lot of issues. Today, if you try to debug a service worker, and you have network requests that are happening inside of a service worker, those network requests will only show up inside the F12 instance that's debugging the service worker. That's something that we hope that we'll fix in the future. So just keep that in mind. If you're wondering where those network requests are coming or where they are, check the service worker F12 instance, which will have them there. Another thing to keep in mind, notifications are going to be integrated into Windows, which is a radical departure about how the other browsers are doing it. What this means is if you have a notification that shows up here and you don't act on it immediately, it will get tucked away in the Action Center so that you can act on it later. In fact, it has all the other features of the Action Center, so you can mute it from here and you can do other things. And of course, there's also a way to manage those permissions. If you go under the settings and then go to advanced settings, and then under the website permissions, you click there, you'll see all the applications that you've given permissions for notifications for, and you can revoke those permissions from there. You're also able to do that in the padlock if you've already allowed the permissions for that site. A quick note on storage quotas. So today, with IndexedDB, you may be aware of our matrix of the different volume sizes and what storage you're afforded based on the domain limit and also the overall limit. So we've decided that we want to simplify this, make it more in line with what Chrome and Firefox are doing. So we're taking that domain limit and we're making it simpler. We're just saying 20% of the overall. You're still going to have the overall limit, though, based on the device size. Obviously, you want less space for smaller devices. At the same time, note that now we're also including caches here and the service worker script files, which are all part of the same quota system. So it's not disparate between IndexedDB and caches. It's all in one, much like what you'll see in Chrome and Firefox and the other browsers. So with that, I'd encourage you guys to use the Windows Insider Preview and enable it today, and you can try it out. You can give us your feedback and let us know what you think. We're very excited about this feature, and we'd love to hear what you guys think. I'll be upstairs if you have any questions or if you want to know any other places you can check out in Seattle. I'll be at the Debug Bar. Awesome. Thanks so much.